In this video, I'm going to do a quick example of ray diagrams for both concave mirrors and convex mirrors. I'm just going to do ray diagrams because it seems like we're doing okay with the equations, and then I'll make another video with lenses. So for concave mirrors like this one, I drew the focal point, and there's your image, and then we always draw the mirror on just a plane, but so my mirror is just hanging out in this plane. Even though I know it really has some curve, we're going to ignore the curve every time we draw them. Now, I'm going to warn you, this app that I'm using is not great for straight lines, so bear with me. The first line comes in parallel. Okay, that's not great. And then it comes out through the focal point. Oh man, I messed this up already. Okay, it comes in parallel, and then it comes out through the focal point. That's where it reflects. Mirrors are always operating under reflection. The second ray does the opposite. It comes in from the object to the focal point to the mirror. And we'll try it there. And then it reflects parallel. The final object, you don't have to. You could say, well, the image should appear right about there. Just to show you how bad I am, the final one that you could do is it comes into the center, and then it will also leave through the center. So I'm going to cheat. It really should have come up here. I'm going to cheat my line. So that means wherever those three intersect, right about here. Oh, I won't do it in green. I'll do it right somewhere around here. Here's my image. In this case, it's inverted. It's a real image. In the second example, I'm going to do this for a convex mirror. So again, the convex mirror is also known as a diverging mirror. The focal point, I drew on the wrong side. Let's fix that. The focal point for a convex mirror, for mirrors, the focal point always shows where they, oh, it's not letting me erase. Okay. The focal point should actually be somewhere over here. It always shows where that mirror curves. There's also, we learned about the radius of mirrors. I didn't talk about it on the last one, but a radius, if this focal point's 1, 2, 3, that means the radius is 1, 2, 3 more away. Okay, so the same rays apply when you're working with convex mirrors. It's just that the focal point's on the other side. So it'll come in parallel, just like we did. When it gets to that principal axis, I know that wasn't a very good parallel line, it will reflect as if it came from, it will reflect as if it came from the focal point. Now it's highlighting. Don't highlight. Maybe I will. That actually kind of is cool. It'll look like it came to the focal point, but actually it's going to reflect this way. Maybe I'm just going to stop while I'm ahead. Okay. The next one will look as if it would have gone to the focal point. Maybe I'll just do this. So it'll look like it would have made it to the focal point, but instead, when it hits the mirror, it reflects parallel. Now, if you can see these two reflected lines, this guy and this guy are never actually going to meet. So I'm going to have a virtual line trace back to help me figure out where I'm going to see, like where my eyes will see the image. Again, if you want to, you can do a third ray. I can tell this is going to be a not pretty ray diagram, but comes into the center, also leaves from the center. Oh man, okay. And again, that ray won't actually meet, but if I trace it back, all three of those virtual rays could intersect somewhere right in here. I would get a virtual, upright, smaller image. I hope this helps.